So at the time that I'm putting this video together, the AMD Ryzen 5 and Ryzen 7 9000 series desktop processors are launching tomorrow. So they probably already launched by the time you're watching this, meaning that they're available at Micro Center, Newegg, your favorite retailers. It's Zen 5. 5 is alive and in a new processor core, and with large language models, that is increasingly hard to tell, at least for non-math people. And these, the huge differentiating factor is not that they're Zen 5, it's the new features that they bring. Better AVX 512 support, it's a new, fully redesigned core. Although, for the end user, does the end user really care that it's a new, redesigned core? It's laying the groundwork for things to come in the future, but buyers, right now, what does Zen 5 give me right now? It actually does give you a fair bit. The biggest thing is power savings. Big power savings. And not really a lot of compromises in terms of performance. Almost everything is faster, from 4 to 16%, but there are a couple regressions. We need to talk about that. But before we get to the performance section, let's take a look at the quality of life improvements. Now, this being an AM5 processor, it's going to work on all the same AM5 devices. ASRock's little AM5 machine, or more of our AM5 motherboards. B650, the MSI Mortar Wi-Fi, the X670E Hero. This is one of the launch boards. This is not a new chipset. I mean, there will be a new chipset, but this is not a new chipset. But just because you don't have the new chipset doesn't mean that you can't enjoy the new features. As you see the benchmarks today and you break it down, the thing to understand is that benchmarks that can run with the improved AVX 512 execution are going to show a dramatic AVX 512 execution improvement. Meanwhile, Intel has abandoned AVX 512 on the desktop. So I'm talking things like Cinebench, and to a certain extent Geekbench, depending on what you're looking at inside of Geekbench. And so the performance uplift there, 30, 40, 50% in some cases. I've got some of my own benchmark testing on Linux you should check out on the Level 1 Linux channel. But yeah, a lot of that is attributable to AVX 512. The other major IPC uplift is attributable to the dramatically improved branch prediction, parts of the chip, and everything else. The memory benchmarks are the one regression that stands out in my mind, so I set a trap for the regression to try to trap the regression, and I actually ended up proving that there's not really a regression in memory bandwidth, but it is maybe something to do with the prefetch algorithm or something like that. We'll talk about that in a second. One of the things from Ryzen 7000 and even all the way back to AM4 was how does the memory controller and the memory speed play into one another for the overall speed of the processor. I mean, it's commonly known that Intel processors are less sensitive to memory speed, whereas getting the sweet spot of memory speed and fabric speed and the internal circuitry, the stuff inside the CPU running in the right ratios really helps pull down the latency and improve the overall chip throughput. It's not just a question of getting faster memory. Well, Ryzen 9000 improves on that in a couple of ways. One, the Infinity Fabric clock speed historically, 2 gigahertz, 2000 megahertz. I was testing my CPUs up to 2133, which means that 6400 memory could run in a 1-to-1-to-1 ratio, which is awesome because that's going to bring the latency down to be at parity with our i5 and our i9 systems. And certainly that bears out when I'm doing A64 testing. Weirdly, though, in A64 testing, the overall read memory bandwidth doesn't really improve. And over on the Linux channel, I'm not going to spoil it too much, but in the Linux benchmarks, it does seem to show a memory bandwidth regression. I think this is not actually a regression. I think this is down to the way that the prefetch algorithm works. Now, Geekbench, especially with the 9700X, something interesting happens. The 9600X, in its own right, is pretty good, power envelope, everything else. The 9700X, I get why. Well, there was a bit of a rumor before launch that AMD waffled a bit on the power, the TDP, of the 9700X. It's lower than the 7700X. And I get why there might have been a little bit of waffling, because in heavy multi-core workloads, there is a little bit of a regression. The 7700X can be faster than the 9700X in some multi-core workloads. Not a good look for AMD. With PBO, you can claw that back. And with PBO, generally, you're not going to have any instability issues. You just enable PBO and it's going to work. And so here's the breakdown using Geekbench as kind of a prop to discuss that. Our single core speed, 3326. And our Geekbench multi-core score looks better in aggregate, 16,390 versus 15,292. But if you look at how it breaks down, you can see that some important multi-core tests regress a little bit. Now, is that related to the memory bandwidth anomaly that I was seeing before? I would expect more of a regression, even given the relatively small memory bandwidth difference. There's not, but there is some kind of a heavy multi-core workload regression. Things like a Blender are probably going to suffer just a little bit. If you enable PBO, well, the story changes a little bit. The multi-core score goes to 17,000, which is quite an uplift. If you have a scenario where you want the 8-core, but you think the 12 or the 16-core are overkill, hit me up in the forum, because I'd love to talk to you. I never like to see any regression at all moving from one generation to the next. And there's a lot of quality of life improvements in the Zen 5 architecture over Zen 4, but if you can get a Zen 4 8-core processor on a Steel But if you can get a Zen 4 8-core 7700X on a deal on a sales site, $50, $100 less than the 9700X, I'd have a hard time recommending the 9700X over the 7700X for the multi-core performance demo. Now, the single-core score being as good as it is, you're going to see an uplift in terms of just using the machine interactively. That single-core performance is great for using the machine like a regular workstation. But if you have multi-core workloads where 8 cores does it, but 12 and 16 cores doesn't do it, you're in kind of an awkward position in terms of product selection. But if you're willing to go with PBO, PBO can make up some of that awkwardness. Almost all of it. Pretty much all of it. Except for that memory thing. Welcome to the Zen Den, where I want to do my testing. Now, I don't want to get too long-winded on this, and it's a little bit engagement bait, but this CPU, our 9000 series Ryzen and this board, our Mortar B650, 5600 is officially supported. Now, the Intel fans in the audience may say, finally, AMD is at parity with Intel. No, it turns out AMD actually had the better memory controller all along, the better memory guarantee, 5200 in previous generations, Ryzen 7000. But on a motherboard like our Z790 Godlike with its 4 slots, if you want to run 2 DIMMs on this platform, LGA 1700, Intel actually only guarantees DDR5 4400. I didn't think that was true either, but that is exactly what Intel has told 2 major system integrators that were looking to do RMAs on their Raptor Lake CPUs. DDR5 4400 is what is officially supported when you have 2 slots routed per channel. Doesn't matter if you're using them, just routed. That's the other thing to understand about DDR5 memory, is if you're using 2 slots, well, if you're using 2 sticks of memory, 5600 is what's guaranteed. On an Intel system, that means that your motherboard can only have 2 slots total. On an AMD system, it could be 2 or 4 slots. It's fine. If you are using all 4 slots, only DDR5 3600 is guaranteed. So for the DDR5 platform, my recommendation is to always just use 2 DIMMs, even if you've got 4 DIMMs. It's like, don't be tempted. Don't be tempted. DDR5, 2 48 gig DIMMs giving you 96 gigs of memory. That is a great configuration, and that is a great configuration for these systems. Now, I tested at DDR5 5600 as well as DDR5 6400, and this is the physical hardware configuration for those and the thing that I ran into. But it absolutely blew my mind that Intel said, yeah, DDR5 4400, that's all we guarantee. Okay, a little bit engagement bait, but hey, I'll take it. So what AMD is doing here is pretty genius. They know that their CPU works better when the memory and the fabric and everything else is running in the right ratio. And so if you use it with an insanely fast kit of memory, that doesn't necessarily mean that you're running at the optimal settings for that kit of memory if you just manually set it. The change here in BIOS is giving you a tool that will take your DDR5 8000 and help you find optimal settings so that the fabric is still running at 2000, or if you're lucky, faster than 2000 with a higher ratio. And yeah, that does actually make a difference in the benchmarks, which we'll talk about in just a second. Now, if you're someone that's looking to save power, what about eco mode? Well, eco mode is going to work pretty well for all of these CPUs. AMD doesn't really need to come out with special low wattage CPUs. To be sure, our 8 and our 6 core CPU, the TDP of those, not crazy. The TDP of these CPUs, 65 watts. That means a total socket power of 88 watts, but 66 watts for these CPUs. And notice that they don't come with a bundled cooler. It's going to be up to you to get a cooler. If you get a cooler to enable PBO, you can expect significant performance uplift without really any instability creeping in. At least I didn't have any on my CPUs. You might lose the silicon lottery, of course. It's always a possibility. But for most of the benchmarks here, I was trying to stick to DDR5 5600 and the out-of-the-box defaults, no PBO where I could. That wasn't always true, but we'll talk about that because there's some surprising things. All of these CPUs have a max operational temperature of 95 degrees C, but the operational range is typically going to float between 70 and 90 degrees C. This is an improvement over the 7000 series Ryzen because it is a different silicon design. It distributes the heat more evenly, and so even though the IHS, like mechanically, physically, AMD tells us they have not modified that at all since Ryzen 7000, the temperature profile of these CPUs should be a lot better. That said, AMD does say that these CPUs are designed to run at 95C or less 24/7, or at least their wear leveling and wear indication is at 95 degrees C 24/7, which is really amazing in the current climate of reliability and serviceability that we find ourselves in on desktop CPUs. Good job, Team AMD. Now, if you are one to overclock, PBO Precision Boost 2, it's still there. It's really not changed a lot from Ryzen 7000. I think the reviewer guide, they said no changes. But there is one big change. That is, these CPUs support Curve Shaper. So Curve Shaper is going to be something that I'm going to have to cover in a future video, but it gives you one more data point where you can decide on a per core basis exactly what you want to do in terms of boost power and what the temperature of the CPU is. So this gives you even more fine-grained control. Now, I saw this in person from AMD in Los Angeles, and it looks very, very promising. And that's also where they demoed the MOPP functionality, which looked exactly like what DIY enthusiasts need in order to really take advantage of whatever hardware they put with this. It's like, oh, I'm going to get this particular kit of memory that runs at DDR5 6000, but may have worse timings than a DDR5 kit at 8000 running at a different set of timings that would go well with the Infinity Fabric and the internal CPU machinery. So it's really awesome to see AMD putting all the work in here. It's great. All right, that's enough talking about the CPUs. Let's get to the benchmarks. First up in our benchmarking, the artificial benchmarking, as we always like to do, 3D Mark. Our 3D Mark performance uplift here is significant, and I would encourage you to focus your attention on the single thread performance of our four main CPUs. I wanted to look at a 7800X 3D and a 7950X, which don't really directly compare to either one of these CPUs, but we're mainly looking at the single thread performance and like performance per core. And this also gives us an idea of how much AMD's performance has improved gen on gen. We've also got the Intel 14600K. The important thing to notice here is that the single thread performance is beating our 14600K, which is awesome. Well, which is awesome for AMD. Cinebench is always really interesting, updated for 2024, so this is Cinebench 2024. And with Cinebench, more cores, always more better. But notice our single thread performance here. 134 beats 131 of our 14900K. And benchmarking our 14900K was a little strange. I tried to set our Intel recommended defaults, like the new ones, as of the beginning of August 2024, because that's changed a few times, and motherboard partners don't know, and I don't know. If you've got an Intel system right now, you need to update your BIOS. You might check out some other videos too, because there's some work you're gonna have to put in. Sorry. The other thing that kind of blew my mind is the 9700X got so close to the i5, even though it's only 8 cores and 16 threads. Like, SMT is doing a lot of heavy lifting here. The 16 threads, basically 2 threads per core. AMD got significant performance uplift with their SMT implementation in the 9000 series generation, which is surprising. I also like to run CPU-Z because, CPU-Z single thread and multi-thread. And the breakdown here is about what you would expect. The performance of the 8-core and Intel's i5 are right on par. The i7 from Intel may be a little bit better, but these are all roughly in line with one another. I was hoping the 9700X would be a little closer to the 14900K, but this is just one benchmark. And it is a significant improvement over the 7950X single thread. 3D Mark Firestrike overall, very, very impressive scores here. TimeSpy also breaks down about like you'd expect. The 7800X 3D pulling ahead because of its, more cache, more better. You're hiding latency. Anything that hides latency really good is going to come out on top in TimeSpy. And that's what we see from the 14900K because it is legitimately very low latency, very fast. But at what cost? Now for the gaming benchmarks, I wanted to break it down with a 4090 and a 7900 XTX. The results of that, let's talk about, but, well, because different GPUs behave differently, and is 6 cores enough for modern gaming? Well, probably not if you've got a 7900 XTX or 4090, but let's see how that actually breaks down. All right, so the thing to understand here is that at 1080p, your CPU is the bottleneck, especially when you've got an absurdly expensive GPU. That might not be true if you have a potato class GPU or even a mid-tier GPU, but if you have a really insanely expensive GPU, you can get an idea of which CPU is going to perform better overall, all things being equal, or at least with the two different GPUs and the two different configurations. So with the 4090 at 1080, we can see that the 8-core 9700X does actually perform really impressively. The i9 and the i5 take the crown in terms of overall average performance, but our 1% lows and our 0.1% lows seem to be a little bit better on the higher core parts. This is also one of those tests where I wanted to show the importance of the memory speed. So DDR5 5600 again, officially supported. That makes a bigger difference than you would think versus running at 6400. Now that is with a 2133 fabric speed, but that is still in a good ratio. And that also brought our latency down, an 8 to 64 and everything else. Still, even with all that, at 1080, it couldn't quite match the performance of the i5 or the i9. But if you want to play at a higher resolution, the story changes quite a bit. At 1440p, the gap is nearly closed. I mean, it's still in favor of the i5 and the i9, but our 8-core CPU here is performing about as well. And if you were playing this game, you probably wouldn't notice a difference between these different performance levels. And surprisingly, the 9700X does actually pull ahead of the 7800X 3D, which has more cache. Assassin's Creed Mirage is also able to take better use of more cores and more threads, and so it does struggle a little bit on the 6-core. Now at 4K, the 9700X pulls ahead of everything else AMD has to offer, and is nearly performance parity with the i5 and the i9 from Intel. What if we swap out the 4090 for the 7900 XTX? Well, at 1080p, the 7800X 3D pulls ahead of everything, but its 0.1% lows are worse than everything. Meanwhile, the 9700X has a better overall 0.1% low, but a somewhat lower overall average. And the Intel CPUs are doing a little bit better. Not by much. Real world performance, this isn't terrible. At 1440p, the gaps pretty much close up with the 7900 XTX. And basically everything in this graph will offer an amazing gameplay experience, even the 6-core, but the 6-core does fall behind. And the 7950X has the worst 0.1% lows of any CPU in the bunch. But still, interesting. Now, 4K, our averages are basically identical. It's just down to the 1% lows and the 0.1% lows. And those are so close to be within margin of error, except possibly the 7950X. Now, the 7950X performing here and in the last benchmark made me think this is down to scheduling or some other thing you could probably fix with process lasso. But yeah. But other than the 1% and the 0.1% lows, the performance here is pretty comparable. And being able to play 90 FPS at this visual fidelity at 4K on the 7900 XTX, pretty swanky. Cyberpunk 2077 is another interesting one, especially because ray tracing is also a little bit of a variable here. Cyberpunk is also not super optimized to know about which core to run on, so our i5 was actually running with a higher average FPS. This is repeatable, even though the 0.1% lows were much, much worse. And that's because there probably wasn't enough performance cores to go around for everything that Cyberpunk wanted to do. Meanwhile, the 14900K came out on top basically, but the 7800X 3D is not far behind and with better 1% and 0.1% lows. Now, the 9700X and the 9600X perform similarly in Cyberpunk 2077, but if you give the 9600 DDR5 6400 and you're running at a fabric speed of 2133, you can actually make up a lot of performance at 1080p in Cyberpunk. And remember, we switch back to the 4090 for this part of the benchmark. When we move up to 1440p, the 7950X takes the lead, and the 9700X is showing very similar performance to the i5, and comparable performance to the i9. The i9 does pull ahead in the 0.1% lows, but the averages are basically the same. At 4K, the 9700X does offer a reasonable 4K gaming experience, but it doesn't come out on top. The 9600X does also seem to perform a little bit better than the i5 14600, and it's basically a wash between the i5 and the 9600X 6-core. Switching over to the 7900 XTX, it's a breakdown about like you'd imagine. The surprise here is that the 6-core can pull ahead of the 7950X for gaming for both the 1% and the 0.1% lows. Now, the average frame rate on the 6-core is just a little bit less, but for practical matters, that the 6-core is doing this well at 1080p, managing almost 160 FPS, is shocking. As we move up to 1440 with Cyberpunk, the gaps get much closer. It's really just down to the 1% and the 0.1% lows. We're basically looking at 130 to 140 FPS across the board. And the 9700X really is performing at parity with the 14900K. Well, the 0.1% and the 1% lows on the 14900K are a little better. For 4K, the performance is basically identical. All of these CPUs keep up. The 9600X, maybe you would be alarmed by the 0.1% lows being a little bit lower, but from an academic standpoint and actually playing on this thing, it was surprisingly good. Now with ray tracing changes the game a little bit, doesn't it? The i9 and the i5 come out on top again, but the 7900X really isn't far behind with 133 frames per second average down to 62 FPS for a 0.1% lows. It's a very good It's a very good gameplay experience at 1080p. At 1440p, our averages come way down to just around 80 to 85 FPS, but the 9600X and the 9700X really are doing well. Interestingly, the 9700X pulls ahead of the i9 at 4K for the 1% and the 0.1% lows, even though it's about 3 frames per second on average slower. Counter-Strike 2 is also a good just CPU benchmark, and yeah, the 9700X here, holding its own against the 7800X 3D, really bodes well for future V-Cache processors from AMD. This is a very impressive result. When we step up the resolution for CS2, the story changes a little bit. CS2 for both the 7800X 3D and the 9700X has equal performance to the 14900K, but better 1% and 0.1% lows. This is a very impressive showing from AMD and their chiplet design. Interestingly, at 1080p, the 7900 XTX seems to be a better showing than the 4090 in terms of overall performance. I guess everything is over 350 FPS. No one really needs to play CS2 at 350 FPS. It's a little absurd, but it is a good CPU test maybe. Horizon Forbidden West is also a popular title to benchmark with, and the spread from 160 FPS with our 6-core CPU at 5600 to 190 FPS with our 14900K is a pretty decent spread. Really similar performance for all of the CPUs in this title. Easily a very enjoyable play experience because you're over 120 FPS basically across the board, and even our 1% lows and our 0.1% lows are pretty consistent. At 1080p, the Intel CPUs pull ahead, but the 9700X, this is perfectly reasonable gameplay experience. At 1440p, the gap closes significantly, and then by the time you're playing 4K, only the 14900K can beat the 7950X or the 9700X. Even the 9600X is pulling ahead of the 14600K, which is very impressive. Similar performance from all of these CPUs though. The spread is only 100 FPS to 106 FPS average. There's not really any outliers in the 1% or the 0.1% lows either. So basically all of these CPUs, I would say, perform essentially the same at 4K. With the 7900 XTX, the performance is really similar across all the CPUs except the 9600X, which falls a little behind all the other CPUs. At 1440p, the gaps close up and the performance is pretty much the same, with the exception of the 7950X, where the 1% lows and the 0.1% lows are a little lower, probably owing to the dual chiplet design. At 4K, interestingly, the 9700X takes the lead with 82 FPS and better 1% and 0.1% lows, better even than the 7800X 3D. I'm not sure what to make of that. To be sure, in our spread here from 76 to 82 FPS, there's really not a lot of difference in the performance that you would experience. I'm a little worried about the 0.1% lows in the 7800X 3D, but that may be something to explore another time. For Starfield, our spread is 107 to 149 FPS. This is another title that I wanted to call attention to the memory speed. At 5600, our 6-core really suffers more than it probably should. I mean, the difference between 107 FPS average and 120 FPS average with our 4090 at 1080p really shouldn't have this much of a spread, but it does. Also, I've included the 9700X 0.1% lows for 70 FPS here. Don't read too much into this because on the multiple successive runs of Starfield, the 0.1% lows were basically all over the place. I just got 2 or 3 bad runs of Starfield in a row on the 9700X and just decided to roll with it. I think this is more of a Starfield thing than an AMD thing or even a driver thing. Moving up to 1440p, the performance spread narrows significantly. The i5 has a strange 1% and 0.1% lows experience, the worst of the bunch, but the 9600X 6-core also doesn't fare well either. For the 9600X and up, it's essentially the same gameplay experience, possibly with the dual CCD problem on the 7950X maybe being a thing to worry about. And at 4K, the performance is basically identical, even for the 6-core. Curiously here, the 14900K and its 1% and 0.1% lows doesn't do as well as the other CPUs. That's odd. The 9700X also has a slightly lower average frame rate, but better 1% and 0.1% lows, but also equally strange, the 9600X 6-core has even better 0.1% and 1% lows. And the 7800X 3D is roughly in line with that, so I don't know. Make of this what you will. Starfield. This seems like Starfield being janky. Switching over to the 7900 XTX, things stabilize a bit. The i9 seems to present pretty solid performance here with the lowest 0.1% lows, but accepting that, the performance of the other processors is very, very similar. I like the performance of the 9700X here, almost able to maintain 120 FPS average. If you played with the graphical settings, you could definitely do it. And the 6-core pulls a little ahead of even the 7950X. At 1440p, the gap narrows, and the spread's only 89 to 103 FPS, with very similar results for the 1% and the 0.1% lows. And at 4K, the performance on all of these CPUs is very, very similar. It seems like the best overall gameplay experience at 4K is with the 96 or 9700X. Now, the gameplay results are really interesting because depending on what kind of a story you want to tell with gameplay, you can say, oh, I really wish these CPUs were faster, or holy crap, a 6-core CPU can hold its own at 4K. From where I'm sitting, the fact that a 6-core CPU can hold its own at 4K, mostly, is very, very impressive. Overall, I don't think it's unreasonable for AMD to claim 16% geo mean uplift in gaming performance overall, 5 to 8% depending on what you want to do. Maybe this would be a little different if we had GPUs faster than the 7900 XTX or the 4090, but with where we are today and the artificial benchmarks and the overall single-thread core performance and just the responsiveness of the system, these older X670 motherboards, this is a very impressive accomplishment from AMD that they've been able to basically roll out a whole new CPU that lays the groundwork for a whole bunch of stuff they're going to do in the future, and that it works as well as it does and doesn't have any significant regressions as far as gameplay and everything else goes. Nice job. I mean, look, for most of these games, they match the performance of a CPU that has the 3D V-cache without 3D V-cache. There's a gaming super weapon coming with 9000 series CPUs that have V-cache if these CPUs are doing this well. I can't wait to get my hands on the 12 and 16 cores. Now, again, those CPUs are going to be more oriented for productivity tasks or power users like me versus gaming. The 9700X is a pretty good choice for gaming by itself. Overall, it is very impressive how much AMD has been able to close the gap over the, insanely roided out 250 watt CPUs that Intel has for gaming. And then I come back to the power and I look at this, and AMD is doing this in their 65 watt TDP, 88 watt board power envelope. That's lower power than the 13700T, which is a 35 watt part that can be 106 watts most of the time. And in eco mode, it doesn't really make a whole lot of difference for gaming type workloads. It's really the multi-core workloads and some of the other stuff. So that AMD has done this in the power envelope that they've done it is shocking. It's quite shocking. And where AMD suffers is really the things that are more latency sensitive. But with the new features that AMD has added to the platform to be able to deal with faster memory kits and things like that, as we saw on the 6-core, you can make up a lot of that difference and get comparable latencies to the Intel platform now on the AMD platform, which is exciting. And it's very exciting for the future that this Zen 5 foundation is what AMD is going to build on for the next couple of CPUs. Fun times. All right, so bottom line, 6 or 8 core CPU, what makes sense? Well, if you follow this channel for a long time, you know that I crave compute. And generally, when I'm looking at this through the lens of someone that has a machine that they're going to set up for 3, 5+ years and beyond. The 6-core CPU gives you an inexpensive CPU that is cheaper than the previous generation CPU that is actually quite competitive. I mean, the single-thread performance here mean that these 6 cores are actually really fast. In some scenarios, it could be a really viable option. Myself, I'm holding out for the 12 and 16 core varieties because, if you're going to go all in, you might as well go all in. But the 8 core is a nice all-rounder, I think, because you get the same high single-core boosts, but you've also got 8 cores and 16 threads to work with, and you get full DDR5 support, all the enthusiast features, and at a very low power envelope. In a lot of ways, that 9000 series CPU is a better choice for something like this than the 12 or the 16 core counterpart because of the reduced power usage, but you could actually get away with a 12 or a 16 core part in this, especially the 16 core in eco mode, even though this thing was not designed to deal with 170 watt TDP CPUs. The 8 core, of course, will run exactly like it was designed to in a platform like this, even though it's got a potato class CPU cooler, which is impressive and shocking, really. The wider support and wider memory kit compatibility running at settings that will be optimized for the way that AMD has designed their CPU is, of course, nice. The biggest detractors will be, well, wait a minute, what about that memory bandwidth anomaly? Has AMD regressed there? And I think the real answer is no, but in benchmarks, it looks a little squirrely, so it's something that I really do need to investigate, because the actual performance is higher when you're running code and applications. Things that are memory bound. Things like, I've been given to study game servers lately in sort of a wide and nondescript kind of a way. And a lot of the time, the game servers are very, very memory bound and sometimes I/O bound. And these CPUs have significant performance uplift over their 7000 series counterparts, which is not what you'd expect if the memory bandwidth was actually lower. So I don't think the memory bandwidth is actually lower. It's probably just something squirrely in a prefetch algorithm or something like that. Maybe something AMD folks can look into. Maybe they can back channel and let me know. I don't think it's anything to worry about. I don't think it's actually a regression. It's just an anomaly in the benchmarks. But it spooked me. And I also haven't really had a lot of time with these CPUs. What with the delay for launch and everything else, we only get like 5 working days or something with these. And so it's just like, it's enough time to kick the tires and take a look. Again, I don't think anything nefarious is going on there. I think it's just compressed timeline. The general software maturity of the RDNA 2 that's actually on both of these CPUs is also really nice to see now, because if you tried Open Broadcaster, or you try to use the AV1, or try to use any of the hardware facilities when Ryzen 7000 launched, software wasn't ready yet. Well, time has passed, and now the software is actually ready. OBS is basically a first-class experience when we're talking about using the iGPU on these. There's no reason to disable the iGPU. You get some nice functionality there. And it's nice to see the rest of AMD software ecosystem come up, which is awesome. And it's nice to see improved memory support and everything else, and Ryzen Master and Adrenaline. AMD is really killing it. A place where they're not killing it is the NVMe RAID stuff, which really hasn't changed since Ryzen 7000. That might change on 800 series motherboards, but it's basically a software-based RAID, and it is definitely not fabulous still. This is definitely an area where AMD can improve for enthusiasts. I want to run dual T705s because this CPU has all kinds of PCIe bandwidth. Just get the one. The one Gen 5 storage, and go on up to Threadripper if you want more. So there you go. These are the first 2 Zen 5 CPUs. Check out the Linux channel review if you haven't already. Number 5 has brought us a look at Zen 5 or Zen 5, and maybe we can put a large language model. It's it's a wild. We can actually build the toy from the movie at this point and give it some intelligence, which is amazing. I cannot wait for the 12 and 16 core CPUs. Be on the lookout for that video. Get subscribed if you're not, or check in or say hello, or if you have anything that you want me to run or test or do something with in the forum, let me know. If you're wondering, should you upgrade? Basically, if you're on Alder Lake, no. Any Alder Lake or anything newer on the Intel side, no. If you have a 5900 or a 5900X, you probably could make it to Zen 6. This is a nice upgrade. If you're on Zen 2, you're on a Ryzen 3000 series, and you're on AM4, and you're tempted to go for that 5800X 3D, this could be a good choice for you, especially like the 12 or the 16 core, or possibly the 9000 series X3D, if that's coming in hot. I have no reason to believe it's coming in hot. It could be 6 months away. I don't know. Might be waiting a little bit. Maybe you get the 6 core to tide you over, because the 6 core single thread performance is so much better. You could enable the platform, do all the other stuff. I don't know. If I were on like a 3900X, if I were on a 3900X, and I had a choice between like the 5900 XT, or which is the new slightly less expensive 16 core, or moving to AM5, I would probably move to AM5. That AM4 system is still worth a lot used around the secondary market because it is so upgradable, and it looks like AMD is shaping up to do the same thing with the AM5 platform. it will go down in the annals of history as nothing short of legendary that AMD was able to keep the AM4 platform around as long as they have been with as many CPUs as they have. So depending on what your position is, leverage that, even though these are nice new CPUs, but people buying these CPUs are going to be getting rid of their older AM4 systems. Now might be a good opportunity for you if you don't want to live on the bleeding edge. But so far, the single thread performance of the 8-core has me salivating for the 16-core. I get 2 of these in one package with this kind of performance. I'll take it. That sounds pretty good. Oh, one last thing. With the new BIOS updates, AMD has improved not just the error-correcting memory that I mentioned before, but also suspend to RAM, sleep states. That generally is working better on these CPUs with the launch day BIOSes for these CPUs, even on 7000 series processors. So if you experienced headaches ranging from annoyance to Lovecraftian nightmares, it seems like basically all of that has been taken care of on flagship AM5 motherboards. So retry if you tried that in the past. You might be surprised how well that works today in 2024. I'm Wendell, Level 1. I'm signing out. You can find me in the Level 1 forums. If I missed anything or got anything wrong or you're struggling with something, let me know. Let's go hang out in the forums. All right, I'm signing out, and I'll see you there.